DRM in non-TMS environment. But for TMS, the TMS comprises of TKS and TPS subsystems. So for token management, you need TKS and TPS subsystems. Otherwise, you don't need it. So it's a simple overview. For clarity's sake, I'm trying to give a pictorial view of non-TMS environment. So you have the certificate manager, which is the certificate authority in the center, which receives requests from users. There is an RA, which keeps receiving requests from users. OCSP responder keeps getting requests for certificate status verification. And then there is a KRA, where key recovery archival requests are sent and retrieval requests are received. So this is just an overview. And if smart cards are involved in this subsystem, in the configuration system, you can have TPS, TKS, and ESC. ESC stands for Enterprise Security Client. So these three components are useful while managing smart cards. So for storing keys and certificates, whenever a subsystem instance is created, like any of the 6 subsystems, by default, Mozilla MSS databases are created along the instance to store certificates and keys. For more security, we could also use hardware security modules to offload the SSL acceleration and to support a different range of algorithms like ECC and ECC, essentially. RSA is supported by Mozilla MSS as well. And these are the 2 HSMs which are tested with Encipher and SafeNet.
Doesn't NSS have support for ECC?
There is experimental stuff which is going on. You can create requests, ECC requests, but it's not completely available. Certicom holds the patents for the ECC. So there are 3 different interfaces available usually. Let's say for a certificate authority subsystem, the first is an entity, and the other one is an agent, and the third one is an admin. Where entity do usual things like retrieving certificates or enrolling, requesting certificate requests. You could install certificate requests, certificates which are already approved. You could revoke client authenticated revocation. You could submit revocation requests. You could also retrieve CRLs and install them in the browser. An agent interface, for a certificate authority agent interface, you could see that would usually approve your certificate requests, and certificates are generated. You could also revoke and publish CRLs to different locations like LDAP to a simple flat file, which can be accessed via HTTP as well. And the third one is an admin interface. An admin interface can be used to configure several things like logs, SCEP, and you could configure plenty of other things. ACLs, access control lists, publishing, and OCSP settings. Plenty of things to configure via admin interface. And simple groups, users. There's a concept of groups and users, where you could assign a particular user to a particular group, like an administrator, or a certificate manager role, certificate agent role, CA agent role, or a DRM agent role. DRM is a data recovery manager agent role. So there is a Java-based console which can be used to manage it, but there are plans to scrap that later on. There are upstream plans and design work is going on to scrap that and make a web interface, but that's just grand plan at the moment. With any of these PKI kind of systems, for high availability, it's called cloning in PKI dogtag parlance. We call it as cloning. So you could clone different subsystems, so that if the master instance goes down due to power outages or any other unplanned problems, the clone or the slave can take up the service request seamlessly and then serve the services. So LDAP acts as the backend database for subsystems. So you can have only one LDAP instance. 389DS LDAP instance is used. I don't know how many of you heard of 389DS or erstwhile Fedora Directory Server. Erstwhile. Just the name is Fedora Directory Server, but the branding is done recently to identify it as a upstream, not associated in specific distro. So one LDAP instance is used to configure all subsystems, and for a clone also, obviously we need a different new LDAP instance so that replication can happen between the master and the clone instance. Usually a load balancer kind of thing is used to serve out the HTTP requests along between the masters and clones. So this is just an overview of CA, OCSP, and DRM cloning and how the replication happens. CA keeps publishing CRLs to the OCSP responder, and OCSP can serve requests. There's a client, there's a command line tool which could be used to query for certificate validation. OCSP client, it's called OCSP client. The tool is called, so which could be useful to query certificate status. Okay. So security, like we just spoke about it. There are plenty of logs available in the system for every transaction, errors, and debugs, and for HTTP activities. Every event is logged, and every event is audited, and every event is signed. So every event which is triggered in the system has an authentication audit message and an authorization audit message, and ensures that the proper role is performing the proper event which is taking place. So there are a couple of different types of authentication mechanisms. One is the regular user password type of client authentication, and then there is SSL authentication and LDAP-based user authentication to request certificates. And SLNX, I'm sure many of you have used it and heard of it. So SLNX is extensively used to have specific, every file, every process, every port has a specific context, which provides much more security to the each and every subsystem in the API system. So yeah, there are a bunch of tools available, which if there's a web interface usually to configure, to put through the configuration of each and every subsystem instance. But if you want to configure plenty of them, it might get a little tedious. So there are a couple of tools. PKI Silent is a silent configuration tool which can be used to configure subsystems and with a simple script and configure as many, to trigger off as many instances as possible. The PKI Create, it's actually a two-step process. Once we install the packages, first we create an instance of subsystem, then we configure the subsystem. So PKI Create will create an instance of subsystem like a CA or a KRA or an OCSP or a registration authority, a TKS or TPS. PKI Remove just states, obviously, can remove an instance of a subsystem. And there are a couple more tools which can use to generate requests, PKCS10 and CRMF, OCSP client, which can be used to query for certificates, revoker and SSL get. These are pretty useful tools which could be easily used by these simple command line options. TPS client is a useful utility which can be used to debug and testing smart card based work. It's usually used to simulate enrollment and formats of tokens. So it's a nice nifty utility. It's just I don't know how clear it is from the looks of it. Just an example of an instance creation. You provide a root of the instance wherever you want to create, and the name of the instance. Let's say for a subsystem like CA and the subsystem type you provide, and you provide several ports for accesses of different services, just like we discussed, an entity interface, an agent interface, an administrator interface, and regular. It's all created with a specific user, which is and a group of PKI user, and the final options are obvious: the log locations and verbosity. I'll just show a little demo. Is this visible? Yes. Yep. So I already have created a couple of instances for CA, CA and KRA, just in case. So just to deal with this is a script which I set. So to see the status. System CDO is a system D utility. It's just a new replacement of init system. I don't know how many of you have heard of system D utility, and this it's already installed and configured. You could see the instance. PKI control. It shows PKI control. We're trying to see what is the status and what type of subsystem, which is a CA, and the instance name. Instance name is PKI CA. So these are different services available for each. This is an agent interface through which CA can accept and approve requests or revoke certificates. The other is an entity interface, which can securely, users can request certificates and submit revocation requests and retrieve CRLs and certificates. And there is an admin interface through which you can configure. Admin is usually used with a tool called PKI console, Java-based console, to configure subsystems with different several options, like LDAP publishing, logging, all this sort of stuff can be configured to help. Just everything is the same. The instance creation is more or less the same. Just you provide. This is for key recovery authority. You create an instance and just again provide the instance name and provide a different set of ports and user and group and configuration file location and logs. Just a simple word. Silent configuration. So this how it goes like this. We just provide a host and instance name, and then provide the ports which we provided while creating an instance, and then provide a security database. And this is an NSS, Mozilla NSS database location, where I just created that directory and created a simple NSS DB using a tool called certutil. And then I provided a simple password, and we would of course use a more sensible one. And it tries to grab for a pre-op pin. It's a pin which it uses to configure it via web interface, and then a couple of other options which can be used to specify the key sizes and algorithms and password for the LDAP database and algorithms for each subsystem has its own subsystem certificates. So just providing different algorithm options there, and just again variable after you define it, we just run the PKI silent tool. We just configure and trigger it off. The CA configuration goes like this. It's a bunch of text. It's on the console. It's not ready. There is a plan. There's a rework plan going on to use this much more cleaner configuration file to provide all the options so that you can just trigger off instances and configure them. So once the configuration is done, on the web interface it looks like that. And an entity interface where you can perform regular enrollments using several different profiles for requesting certificates, and you could also provide revocation requests and retrieve certificates. And this is the agent interface, which I got it via this one. It is client authenticated interface, client SSL client interface, and there's an OCSP agent interface where you could add different certificate authorities to query certificate statuses and check essentially if the certificate is valid or not. And there's a DRM agent interface where you could provide whenever a profile is used to archive your private keys. Of course, only encryption private keys are archived. So this archives you can retrieve your archive keys from the subsystem. Yeah, that's just a quick but very fast overview of the subsystems. Yeah, what's coming next? There is a design going on for having a REST-based interface, and a lot of dependencies are in JBoss. They're being packaged for Fedora first. It's inherently slightly difficult to package jars. So there's a lot of work going on. I think as of now there's packaging work going on as we speak somewhere else, in one of the rooms, hacker rooms. And then there is a tight integration of all the subsystems into FreeIPA project. I don't know how many of you heard of FreeIPA project. 2009 FOSDEM, I guess, CMOS source presented. I'm one of the lead developers. So it's an open source free identity solution which integrates several technologies like Kerberos, DNS, LDAP, and all this, and glued together so that it's seamless to manage identity. So at the moment, CA is already integrated into the FreeIPA project, but the other subsystems are being planned to integrate them. And there's a lot of rework and always refactoring going on in the code. And the tools are also improved by being written in Python, so that it's much more cleanly configurable than existing setups. So yeah, there are some resources. Hop onto the IRC list, channels, mailing list. People are not that bad, they're friendly enough. So yeah, I think if you have any questions, I'd be happy to take.
Can you just give a quick overview of how you would issue a smart card with this? Because you said you have smart card, or is that outside of this?
It's outside. I don't have a smart card with me. The chamarthy cards, which I myself usually test with a TPS client, a software emulation of it. Unfortunately, I don't have it handy with it, but I can show you offline once it is done. So how you want to?
Not real thing. Just an overview. Just the steps. What are the steps that you have to go through?
Yeah, there's an enterprise security client. You use a smart card, and there's a TPS subsystem, and you provide information, whatever you need, the user, blah blah blah, and then you write in, you approve request, C approves the request, and then you can take it out. Enterprise security client is the
you have to bring the token to the CA system. Okay, so you can't do it remotely.
I haven't done the remote one, but I could check that for you.
Okay.
I have two questions.
Sure.
You mentioned JBoss, so I guess that's how you reach scalability in terms of the interface towards the client.
Sorry, can you repeat that?
You're using JBoss, is this correct?
No, not at the moment. Now there's plan to use some REST-based interface, but at the moment, no.
Okay. Okay. And you mentioned a database and replication. What technology are you using there? Are you using?
Oh, LDAP. It's when the
LDAP
backend
is,
is, yeah, it's 389 LDAP instance which is used. Single LDAP instance is fine enough to configure all subsystems. There is no need to have a different LDAP instance to configure each and every subsystem. But to have a clone instance of the master CA or any of the subsystems, you do require a different LDAP instance. Does that answer your question?
Yes.
What's your current? Do you have support for international sites like Unicode, UTF?
Yeah, there is support for internationalization. Yes, there is.
I've heard that at some point there was a problem with that.
Probably there must be an occasional bug or two, but I'm sure there is UTF. There was some tests people have done with that. Sure.
I forgot my second question.
Yeah.
The second question was, what protocols do you support? You mentioned PTC is 10.
Yeah, because
And
CRMF and the CMC,
Okay.
CMC, CRMF, yes. And ECC is also supported, but that is when you generate keys on the HSM, either on Luna or SafeNet, sorry, Encipher.
I think there was also key recovery in the first picture. How does that work?
Key recovery authority.
Yeah, like the amount of plain text.
The amount of?
The amount of plain text in the system.
Could you rephrase that?
I mean, plain text keys.
I don't think there will be any plain text in the system. It's mostly encrypted in the NSS databases, or if you're using you can configure LDAP with SSL. So the LDAP instance with SSL, where all the information is stored.
Yeah, but I mean, plain text keys used for recovery outside of the hardware container.
I don't think so. No, they're not used.
No?
No. I could show that to you once it's done.
They support like CMP protocol and other something like that.
Say again, sorry.
CMP protocol, you know, RFC 4210. No, there's CMP, Certificate Management Protocol, RFC 4210.
I think it is reported.
Does UTVC
Of course.
use it extensively?
Well, it's become more popular. There's a standard for 4G LTE networks where they use CMP.
Any other questions? Okay. Thank you very much. That's it. Was there any comprehensible at all?
Yeah, it was very good. Thank you.
If you have any painful must be done, then skip the food. Like, we'll try. Just keep an eye on it. What could have been better? That's right. I tried to use it, but it's just.
Okay, all the recordings, but
Yeah, it's